So section 4.2, we want to learn about linear functions and their graphs. So let's start out with the definition. A linear function. A linear function. F in the variable x is any function that can be written in the form f of x equals mx plus b, where m and b are real numbers. If m is not equal to 0, f of x equals mx plus b is also called a first degree polynomial function. And it's called first degree because the degree on x is an understood what? 1. Very good. So that's why it's called first degree. Because the exponent on x is an understood 1 here. Make sure your phones are silenced. Okay? So this looks familiar because we've been talking about linear functions all along. Okay? So we just have the official definition. So now what we want to do is we want to graph the following linear functions. We want to graph the following linear functions. Part A, we have g of x equals 3x minus 2 over 4. It will help for us to get this linear function in what form? What standard? Get it into y equals mx plus b form. Get it into this form, which we know is what kind of form? We talked about this last time.
Slope, right?
It's what? It's slope form? Say it again. Y-intercept only? Put them together. Put what both of you said together. Slope-intercept form. This is a linear function when you have y equals mx plus b is the same thing as slope-intercept form. Good morning. This is the same thing as slope-intercept form. I've already taken attendance, so make sure you see me after class. So here, we can rewrite this as 3 over 4x minus what? Minus what? Minus 2? 2 over 4, very good. 2 over 4 is the same thing as what? 1/2, good. So that linear equation is the same thing as 3/4 x minus 1/2. That's just another way of rewriting g of x. So using what you know, what should we plot on our coordinate plane first? Your y-intercept, very good. In an ordered pair, what is our y-intercept? We know x is what? In an ordered pair, if we're plotting our y-intercept, we know x is what? If you're plotting your y-intercept, x is 0. Very good. X is 0. So we know our x is 0. What is our y? Negative 1/2. Good. So this is our y-intercept. So let's plot our y-intercept is 0, negative 1/2. Let's say that's negative 1/2. Okay, so we have our y-intercept. So now, say 1. We want to plot another point so we can sketch the graph, sketch the line, so we can sketch the graph of our linear function. So how do we find the next point? What do we use? Our m, we use our slope, yes. What is our slope? What's m? Good. M, which is our slope, is 3 over 4. So from negative 1/2, what do we do? Go up 3, right? But remember, we're starting at negative 1/2, so going up 1 is really what? Is it 1 or is it 1/2? 1/2, very good. So 1/2, then we go up 1 more. That's 2, then we go up 1 more. So we're here at 2.5, right? Are you with me, yes or no? You got to respond. So we're at 2.5, and then we go over how many? 4, right? So we're here. Okay, so this point would be 4, 2.5. Okay? Or either 5/2, whichever one you prefer. Okay? So then we have 2 points. We can sketch the graph of our line. There you go. What questions do you have? How many of, go ahead. I can't hear you. Talk loud.
It went up 3 and it went over 4.
Yes. So your slope is rise over run. Your slope is rise over run. So it tells you how many to rise or drop. And then run means you go to the left or the right. You go to the right here. Okay? What other questions do you have?
So you rose 3 and you went over 4?
Yes, that's what he just said. Yes. What other questions do you have? Okay.
Oh, I had a question about what we got.
They can't hear you in the back.
I had a question about what we got, the 4 and the 2.5.
Where did they come from? Where did 4 and 2.5 come from?
Because you gotta go up 3. Once you went up 3, negative 1/2, and then you went over 4.
That's absolutely correct. So we started at negative 1/2. You go up 1, 2, 3. You end up there. And then your denominator tells you to run 4. So you go to the right 4. So that's where that point came from. X is 4, Y is 2.5. What other questions do you have? Yes?
If the denominator,
Talk a little louder.
if the denominator was negative, we go to the left.
That's a good question. So if you have, and it depends on how you do it, if you have 3 over negative 4, then you can rise 3, run to the left 4. You can do that. There are different ways you can play around with it in this case. You can put the negative in the numerator if you wish, and then that can mean you drop 3, run to the right 4. Either way, you're still going to end up on that same line. What other questions do you all have? Okay. All right. So let's look at our next example. This is what this section is all about. We have one more example and we're done here with 4.2. B, we have k of x is equal to 3x minus the quantity 2 plus 6x over 2. So we can simplify a little bit first. So we can rewrite this as 3x minus the quantity. It would be 2 over 2. Go ahead.
Oh, plus 6 over 2. 6 over 2 or and then x.
Yes. Tell me what that simplifies to be.
3x minus 1.
Do we have a parentheses anywhere, or are we just writing minus 1?
Parentheses.
Where?
In front of 1
Okay.
plus 3x. Parentheses.
Okay. And now what? Yes, to get what? Talk loud.
3x minus 1 minus
Talk loud. Oh,
3x minus 1 minus 3x.
good. Now what happens?
Combine like that.
Yes, so what cancels? 3x is canceled, leaving us with -1. So we have k of x equals -1, which is really the same thing as y equals -1. What kind of line is that? Horizontal. Through what? Very good. Horizontal line through -1. So this is k of x equals -1. Very good. Very good. Okay? So that's it. That's section 4.2. A few facts to note. You may need to match a function with its graph, so make sure you're able to identify your slope, your y-intercept. You may be given a graph and you have to identify a formula for the linear function that's depicted in the graph. So you may have to identify what equation matches the graph. So make sure you go through your homework for 4.2. Questions? Okay, that's 4.2.